Hello everyone, welcome to my YouTube channel Fcodes. Today we are diving into the first problem of the Leetcode 150 series, merge sorted arrays. So this is a very simple problem. Before we begin, I want to share that this is a new channel dedicated to teaching coding related topics. We are kicking off the Leetcode 150 series right here, so stay tuned for more. If you enjoy the video, don't forget to subscribe for future content. So let's get started. So we are going to solve this top interview 150 problem, the first problem, which is known as the merge sorted arrays. So let's see what the problem is saying. Actually, this problem is an easy level problem, and what we have to do is that there are two array given, nums1 and nums2, in a sorted in non-decreasing order. Basically, it is sorted in ascending order, and m and n are two integers which represent the numbers of elements in nums1 and nums2 respectively. So what we have to do is that we have to merge nums1 and nums2. Final sorted array should be stored in nums1 only. So let's see. So let's say that we have nums1 given as 1, 2, 3, 0, 0, 0, okay, and nums2 given as 2, 3, and 5. So what we have to do is that these are all sorted in ascending order, okay. This is the element m, and this is the length n, okay, and this is actually n here. So that's why the nums1 size is m plus n. So what we have to do is that we have to merge this array nums1 and nums2, both this array, and the merging should be in order that the final sorted array should be in nums1 only. The final nums1 should look like this: 1, 2, 2, 3, 3, 5. So this is a sorted array, and this sorted array should be in nums1. Okay, we don't have to return anything. Fine. So let's get to the solution part. So the first solution. Okay, I'm not going to into much detail with this first solution because this is a naive approach, and I'm just going to tell you how this works. So we are going to create an array C, okay, the size of which would be m plus n, same as the size of nums1. Then what we will do is that we will push the element of nums1 and nums2 both into this array C, and then we will use the sort function to sort this array C. But what we had to do, we didn't have to initialize a new array and return it. So what we will do is that we will copy this array C into this new array C into nums1. Okay, so it is a very simple solution, and you could do it if you try. Let's move to the next solution. Okay, so now let's see the second approach. Okay, we can use the concept of merge sort here. Okay, merge sort concept, it uses two pointer technique. In the merge sort there is already two sorted array given, so let's consider this 1, 2, 3 and 2, 3 and 6. So we have to merge it. So what we should do, we will put a pointer here I and pointer here j. Okay, fine. Now we would initialize an empty array which would be of size m plus n. Okay, so the size in this case, in this example, would be 6 of array C. This is array C. The size would be 1, 2, 3, 4, 5, 6, 6. Okay, fine. And we will put a pointer k here. Now we will compare both of these indexes, that which value is smaller value. So in this one, in this scenario, here at a position I, the value is 1, and at a position j, the value is 2. So which one is smaller? Definitely the one is smaller. So we will put this one value here, okay, in the array C location. And now we will increment this I pointer and the kth pointer. So whichever value we put here, okay, we will put that index to the next position. Okay, so now the ith is here and k is now here. Now we will again compare that between 2 and 2, which is less than or equal to. Okay, so actually 2 is less than equal to 2. So we will put again put this value 2 here, and now we will increment again I, and we will increment here k. Again we will compare. 3 and 2. Which value is smaller? So 2 is smaller. So we will now put this 2 on this location, okay, and increment this j, because we have put this value here. So we'll increment this pointer to the next location, and in similar manner we will increment this kth pointer. Now we will compare. So 3 is less than is equal to 3, so we'll put this position here, okay, and now we'll increment I here. Now see, the array, the index I is out of bounds, okay. So now we will stop here the procedure for this, and now we will again iterate the value for the array B and put all of these values directly into the array C. So now array the 3 and the 6, the elements 3 and 6 will be directly put into array C. So that's how this works, and you will see that the array C is in the sorted order, but we don't have to use the extra space. In fact, we don't have to return any array. We have to make changes is nums1. So what we can do is we can copy this value to nums1. This will work. So we can do this. Nums1 is equal to array C. This was the second approach, and I think you can code this on your own. You can see the code of the merge sort, and you will figure out that how it is being done. So now let's move to the optimal code solution, okay, where we don't have to use any space for this, and we could directly do all of the things is nums1. Now let's start the third case. So this is the optimal code solution and the third approach. So what we are going to do is that first we will make the arrays. So this is a nums1 where 1, 2, 3, 0, 0 and 0 given, and let's consider nums2 as 2, 4 and 6. Okay, fine. So we will basically make changes is nums1. So here I am going to write nums1 again. So I'm not writing the elements here, but think of it that the element is already present here, that 1, 2, 3 and so on. Okay, 1, 2, 3, 0, 0, 0. But I'm not writing it because I have to make changes in this nums1. Okay, so now what I'm gonna do is that we are gonna start from this last position. Okay, so what I'm trying to say is that we will start from here, the last element position. Okay, at the position M we are gonna put a pointer. In the similar manner, in the last position of nums2 we are gonna put a pointer J, and in the nums1 finally in the nums1 again we are gonna put a pointer K here. Okay, now what I am trying to do is that I am trying to fill the highest element first. Okay, because this is the last element in this nums1 array. This would be the highest element here, and to find the highest element we have to start searching nums1 and nums2 from the last position, because in nums1 and nums2 the biggest element would be at the last position. So now we will compare the position I and j, which value is the greatest value. So the 6 is greater. Now we will put the 6 in this position, and we will decrement this j, and similarly we would decrement this kth pointer. So this is just the same concept as the merge sort we have done in the second approach, but the thing is that we are starting to fill it from the last position. That's the only difference. Rest all are same. Compare again. 3 and 4. Which value is the greatest value? So 4 is the greatest. So we are gonna fill this position with a 4, and now we are gonna decrement this jth pointer, and we are gonna decrement this kth pointer. Now we will compare 2 and 3. Which is the greatest value? 3 is the greatest. So we'll put 3 here, and now we will decrement the ith pointer. Okay, and we will decrement the kth. So now we will compare 2 and 2, which is the highest value or higher value. So both are the equal, so we can consider any one. I am going to consider this value, okay, of the nums2. So we are going to decrement this j, and now this 2 will be decided here, okay, and the k will be here. Now the j is out of bounds, so we will stop the procedure here, and we will get a final answer. How? Because these two positions would be already filled with the value, with the lowest value 1 and 2. You can see here these are the values which are already filled here, because we are considering this nums1 only. Okay, this is the same array, so 1 and 2 are already here, and we have made changes to the last elements, and now we got this sorted value, sorted array. This is a sorted array. Okay, 1 2 2 3 4 6. This is a sorted array. So the time complexity for this approach is just O of m plus n, and the space complexity is O of 1, because we have not used any space for this. So this was a pretty good and very easy solution. Now let's jump to the Leetcode and code the solution. Okay, so what we have to do, first we are going to initialize 3 pointers. I would be at the last position of nums1. Okay, so I would be at m minus 1. Similarly, j would be at n minus 1, and k would be at last position of nums1. So nums1 dot size minus 1. Okay, so we have put the pointers here. Now we are gonna run a loop. So the loop will be till the j is not going out of bounds, because here we have seen that when the j goes out of bound, we stop the iteration. So when the j goes out of bound, we will stop the iteration. So now we will check the condition. First we will check if I is in the boundary, like I should not be out of bounds also. So first we will check that I should be in the boundary. Now we will check that if nums of I, nums1 is greater than nums2 of j. Okay, so we are checking if the value at position I would be greater. What we will do, we will put in nums. So the position, ith position value would be transferred into the kth position. Okay, and then we will decrement the kth pointer and ith pointer. Similarly, in the else condition, what will happen? In the nums1 k, the value of nums2 j will go. Okay, and then we will decrement the kth position and the jth pointer. When the loop will finish, in the nums1 would be in sorted manner. Okay, so this will complete our answer, and let's say if we are able to compile it and get a success message. Okay, so the test cases are accepted. Now submit it and see if there is any error or not. So our solution is submitted and it is accepted. So that's how we have done this question. It was a very simple question, and in the next video we will proceed with the second question of the Leetcode 150. So if you have liked the video, please subscribe for more content like this, and please share the video as much as possible. If you have any problem in this question, you could ask me in the comment section, and I will give my best to explain it further. So thank you very much. Have a nice day.